Hello everybody, in this lecture we will be solving 1978 IMO problem number 1. Here is a view of this problem. We're given two positive integers m and n, and in their decimal representations, the last three digits of 1978 to the mth power is equal to the last three digits of 1978 to the nth power, and we would like to find m and n such that m plus n will be minimized. Let's have a look at first this difference, 1978 to the nth power minus 1978 to the mth power, which is equal to factoring out the 1978 to the mth power, knowing that m is less than n, 1978 to the power n minus m minus 1, and we know this quantity is divisible by 1000, which is, by the way, equal to 2 cubed times 5 cubed, right? The last three digits agreeing with each other is basically telling us that when we subtract them from each other, the last three digits should be 0. But this term does not have, because it's odd, doesn't accept any 2's in it, so therefore it must be the case that 2 cubes, so this implies that 2 cubed divides 1978 to the power m, but recall that 1978 is simply equal to 2 times an odd number, so as a result 2 times let's say 989 to the power m, or simply 2 to the power m times 989 to the power m, so therefore this implies m must be greater than or equal to 3. Now, for the rest of the discussion, what I can do is, because my goal is objective is to minimize, my objective is to minimize m plus n, but m plus n can be written as n minus m plus 2m, and I can easily minimize the m here, so therefore the problem is equivalent to searching for conditions when m is equal to 3, what will be the smallest for this one? Okay, so let's start with the following observation. Let s be the smallest positive integer such that 1978 to the power s is congruent to 1 in mod 125. We did that because somehow we want 5 cubed to divide this whole expression, but obviously there's no 5 inside this expression, so therefore 5 cubed somehow should divide this this second term, and that's exactly what I'm doing here. Okay, so by Euler's theorem, Euler's theorem, I know that 1978 to the power phi of 125 is congruent to 1 in mod 125, that's an O, and it's easy to calculate phi of 125, by the way, which is equal to simplify of 5 cubed as 5 cubed minus 5 squared, which is 125 minus 25, 100. So therefore, the smallest s that satisfies this will definitely divide phi of 125, right? And thus s divides 100, right? So because it is the smallest, right? And we know definitely that 1978 to the power 100 is definitely equal to 1, suggesting that s should divide 100. Now one can easily observe that because 125 divides 1978 to the power s minus 1, it must be the case that 5 also divides 1978 to the power s minus 1, obviously, but this implies that if you check it in mod 5, 1978 to the power s, which is congruent to 3 to the power s, must be congruent to 1 in mod 5, and that would only happen knowing that s divides 100, and also this condition, combining these two, we realize that of the 9 factors, divisors of 100, only 3 of them satisfy this congruence, the second congruence, and those are s is equal to I believe 4, because 3 to the power 4 is 3 squared 9, or 4 squared, which is just 1. Right. So 4, and you can easily check that 20 satisfies it as 100 as well. So for the rest of the proof, I will just show how 4 and 20 won't work actually. So let's start with s equals 4. In that case, 1978 to the 4th power is congruent to, well, in mod 125, that's equivalent to minus 22, right, to the power 4 in mod 125 again, huh? So let me write that down, mod 125, and that's simply congruent to, I can split minus 22 as minus 2 to the power 4 times 11 to the power 4, but minus 2 to the power 4 is just, right, 2 to the power 4, which is just 16. 11 to the power 4 would be, right, 11 squared is just 121, which is minus 4. So minus 4 squared will be 16 as well. So that would give us 16 squared, and 16 squared in mod 125 is equal to 256, which is congruent to 6 mod 125. Yeah, not equal to 1 as we expected, so therefore this won't work. So similarly for s equals to 20, 1978 to the 20th power is the same as 1978 to the 4th power times 1978 to the 16th power, but then I can split it as 4 times 4, and that's simply congruent to 1978 to the 4th power we just established is equal to 6, and 1978 to the 4th power is as a result 6, so this thing is 6, the inside is 6 raised to the 4th power, and this is simply congruent to 6 times 6 raised to the 4th power. I believe one would get 46, and 6 times 46 in mod 125 would simply be equal to 26 and not 1. So therefore we are left with only one option, s is equal to 100. Remember, huh? So s is equal to 100, but since s is the smallest possible integer with 1978 to the power s equals to 1 in mod 125, now it is obvious that we can take as n minus m, we recall that we're trying to minimize n minus m, we can take it as 100, right? So which is equal to n minus m, and therefore this with the smallest possible value of m equals to 3 would imply that n is equal to 103, and thus we found that m plus n, the smallest possible value for m plus n, is equal to 103 plus 3, which is equal to 106, and we are done.